Welcome to lesson 1-8, video 1, intervals of increasing and decreasing. So this is kind of similar to what we looked at in the last video in 1-7, but it's not exactly the same thing. You're gonna give your answers in terms of like an interval of x's, but what it means for a function to be increasing versus decreasing is not the same as if a function is positive or negative. So let's look at what it means for a function to be increasing or decreasing. Alright, so when looking for sections of a graph that are increasing or decreasing, be sure to look at or read the graph from left to right. So I mentioned that earlier, or in the last video, that you want to scan your graph from left to right. So we always read it from left to right. Okay, so let's fill these in. A function is increasing if as x increases, reading from left to right, y also increases. So really what that means is that if you look at a graph from left to right, the graph looks like it's going uphill. And the graph is going to have a positive slope. Okay? And similarly for decreasing, it's just going to be the opposite. Okay? So as you read it from left to right, it should be decreasing. Okay, so as x increases, y is decreasing. So in plain English, it just means that if you look at the graph from left to right, the graph looks like it's going downhill, or it looks like it has a negative slope. All right, so let's look at our example here with our little guy here, Pierre. Looks like he's a little ant. And he looks like here from the left. First off, and I did this in the last video, I went ahead and let me make sure that I have my thickness set here correctly. Yeah. I always like to label the left-hand side of my axis as negative infinity, the right-hand side as positive infinity. So as Pierre moves from left to right here, he's constantly moving up until he reaches this point right here. This is really important for us to understand. So from negative infinity to negative 3, Pierre is increasing. So I'm going to write that right here. From negative infinity to negative 3, and I'm going to put parentheses around this because I do not include negative infinity. I never do with anytime we write these in interval notation. Excuse me, interval notation. But why do I not include negative 3 here? Well, think about it. And the example I used in class today was like if you throw an object up in the air. The object goes up, for a split second it stops, and then it comes back down. So what's happening here at the very top, he is neither increasing or decreasing for a very brief moment. So we don't actually include this value of x right here. So that's why we use a parenthesis. Now, once he gets to the top and he starts working his way back down, it looks like Pierre is decreasing until he gets to 1 right here. So we're going to say, and I'm going to go ahead and label this with an I for increasing here, and then I'll label this one with a D for decreasing. So it looks like he's decreasing from negative 3 until he gets to 1, and I'm going to say not including or non-inclusive here from negative 3 to 1. So we'll say he's decreasing. And then what does Pierre start doing again? He starts increasing, going up again. Okay, so he starts increasing again from 1 to 4 until he gets to this point right here where he just stops moving. So at this point, at 4, until infinity, he is neither increasing or decreasing. All right, so, and we'll say he's neither increasing or decreasing here, and then here he's increasing. So let's write this down right here. You might see problems like this where it asks you, where is the function increasing? Increasing. And where is it decreasing? Okay, so this function is increasing from negative infinity to negative 3, and from 1 to 4. Now, I left a little space here. We'll come back to that in just a second. You could also say this. You could also say that it's increasing where x is less than negative 3 and where x is between 4 and 1. Or really, between these two. So it's increasing between, or when x is less than negative 3, or where x is less than 4 but bigger than 1. All right, so where is it decreasing? So the only part it's decreasing is right here between the interval of negative 3 and 1. Okay, now let me change colors and go back to this other little part here. So we need to include something here. We have to join these two together. And this is called the union symbol. It also means or. So if you, in Delta Math, if you are plugging in your answers and you have more than one interval for an increasing function you have to write down or you have to type in as an answer, you have to either, if you do it in this notation right here, you have to include the union symbol because the union means or. If you write it like this, you must include the word or. All right, let's go on to this next page here. So a couple examples. So example number 1. So this function is actually always increasing. So it's an exponential function. So as you were to move, if you were to, let's put a little stick figure here, as this guy moves from left to right, he's always increasing. So you can either say always, so always increasing, or you could say increasing from negative infinity to positive infinity, non-inclusive, or you could say x is less than infinity but greater than negative infinity, or increasing on all real numbers. Okay, let's look at this one. So this one looks like as we move from left to right, and I always like to write my infinity symbols here, it looks like we're increasing until we get to this point at the very top right here at 2. Okay, so it looks like we're increasing from negative infinity to 2, not inclusive, meaning I do not include 2, because think about it, at the very top here, there's a split second where you're neither increasing or decreasing, you're just there, you're just standing still. And then so you go up, you hit the peak, you stop for a second, and then you come down. So you're neither increasing or decreasing for a second. So we're increasing here, I'm going to get lazy here and write an abbreviation, and we're decreasing from 2 to infinity. So we'll say decreasing. All right, and then lastly, this is a linear function, and this one looks like we're always increasing. So I'm going to write negative infinity, positive infinity. This is a case where you're always increasing. So we're going to say, you can say from negative infinity to positive infinity that we're increasing. You can say that x is less than infinity or greater than negative infinity using set notation. You could also say it's increasing, it's always increasing. You just have to be able to know the difference between those different types of ways of representing the x values there. So intervals of increasing and decreasing always pertain to x values. Do not read numbers off the y-axis. Stay on the x-axis for these intervals. So what I like to say, I like to go a little bit further than that and say you figure out what the y's are doing as you move from left to right. So are the y's increasing or decreasing? That's going to tell you where it's increasing or decreasing. And then you're always going to give your answer in terms of x, okay, or what on the x-axis. Okay, and lastly, a couple things to talk about here. What can you expect? For a linear function, it will always be increasing if there's a positive slope. It will be decreasing always if it's a negative slope. For a quadratic, there's two things that can happen. It's either going to have, well, it's always going to have a vertex, but the parabola is either going to be facing up like this, or it's going to be facing down like this, and that's going to depend whether that's going to tell you whether or not it's going to be increasing first or second, and it will always have a section that's increasing and decreasing. And then lastly, exponential, it will be increasing for growth and then decreasing for decay. And it'll always be all real numbers, okay, for exponential. So it's either going to be always increasing or always decreasing. All right, you have these U tries that you can work on, and I'll see you in the next video.